I was actually pretty surprised when I learned how Bitcoin really works. It's
Yeah.
not at all like having a balance in your bank account.
Right. Most people think of digital money as just a number going up or down on a ledger.
Exactly. Like my online banking. But Bitcoin, well, it just doesn't do that.
Hmm.
It doesn't store account balances like we normally think about them.
Mm-hmm.
It uses
Okay.
this completely different system. Honestly, it's quite fascinating, and it really matters for things like privacy and, well, tracing funds, too.
Definitely.
So today we're going to take a real deep dive into that core mechanism behind, well, every single Bitcoin transaction. It's called the UTXO model.
Yep. UTXO.
And understanding this, it isn't just for, the super technical folks or developers. It's actually essential if you really want to get Bitcoin's privacy features,
Mhm.
how the money actually moves,
Mhm.
and even how investigators track digital assets. We're drawing a lot today from Charlene C's guide on this, which is fantastic for on-chain and OSINT analysis.
Yeah, it's a great resource. And what's really key here is that this isn't just some technical detail you can ignore. It's not jargon.
Right.
This specific design choice, the UTXO model, it's what gives Bitcoin its unique properties. And it's absolutely crucial for what we call on-chain intelligence work.
OSINT stuff.
Exactly, open source intelligence using the blockchain data itself. So for our listeners, whether you're just curious, maybe getting started with OSINT, or you're already a blockchain investigator, maybe in a financial crime unit,
Yeah.
this deep dive should give you a really solid but accessible explanation. We're tailoring this for you.
Okay, let's unpack this then. What exactly is a UTXO?
Okay, so UTXO, it stands for Unspent Transaction Output.
Unspent Transaction Output.
Yeah, think of it like this. Every time someone sends you Bitcoin, your wallet doesn't just add it to a running total.
Mm-hmm.
Instead, it receives this specific recorded chunk of Bitcoin. That's an output from the transaction that sent it to you.
Okay, a chunk.
A chunk, exactly. And that chunk, that output, it can only be spent once in its entirety as an input in a future transaction you make.
Oh, okay.
And until you spend it. Well, that's when it's called an unspent transaction output, a UTXO.
The source had this really good analogy comparing UTXOs to sealed envelopes with money inside.
Yeah, that's a great way to put it.
You can't just open the envelope and take out, say, $10 if there's 50 inside.
Nope.
If you want to use the money in that envelope, you have to spend the entire 50.
The whole thing.
And then if you only needed 10, you'd get 40 back as change, probably in a new envelope.
Exactly. That's the core idea. Bitcoin works with these, well, indivisible chunks.
But wait, that makes me think. If you always have to spend the whole chunk, doesn't that make really small payments, like buying a coffee, kind of
Right.
inefficient? Or maybe not what Bitcoin was originally designed for?
That's a really sharp point. And yeah, you've hit on one of Bitcoin's inherent design trade-offs. It's not fundamentally built for tiny, frequent microtransactions like a credit card is.
Yeah.
That's why you hear so much about things like Dust, these tiny UTXOs that cost more to spend in fees than they're worth.
Right, the dust.
And also why layer 2 solutions like the Lightning Network were developed to handle smaller, faster payments off the main chain. It sort of highlights that Bitcoin's main strength is more like a secure settlement layer for, bigger value transfers.
Gotcha. So connecting back to how a transaction works then.
Right. So every Bitcoin transaction basically has two sides. First, you've got the inputs. These are the UTXOs you already own, the envelopes you're choosing to spend now.
Okay, the ones I received before.
Yep. And second, you've got the outputs. These are the new UTXOs being created by this transaction. These are the new envelopes.
When new one's going out.
Exactly. And the absolute crucial rule, the one you got to remember, is that inputs, the old UTXOs, must be spent in full. Always.
Always the whole envelope.
Always the whole envelope. So if the total value of the UTXOs you're using as inputs is more than what you need to send, the leftover amount comes back to you as a change, exactly. But it comes back as a brand new UTXO, a new output created by that same transaction, usually sent to a new address your wallet controls.
Okay, could you maybe walk us through a quick example?
Sure, yeah. Let's use the one from the source. Say Alice wants to send 0.6 Bitcoin to Bob.
Okay.
Now, Alice checks her wallet, and she doesn't have one single UTXO worth exactly 0.6 BTC.
Yeah.
But she does have two separate ones. One is worth 0.4 BTC, and another is worth 0.3 BTC.
Okay, so 0.7 total.
Right. 0.7 total she controls in those two chunks. So to send Bob the 0.6, she has to use both of those UTXOs as inputs in her transaction.
Spend both envelopes.
Spend both envelopes. Yep. The total input value is 0.7 BTC. Then her transaction creates two outputs. One output sends zero point 0.6 BTC to Bob's address.
That's Bob paid.
Bob's paid. And the second output sends the remaining zero point 0.1 BTC back to Alice herself as change. That creates a new zero point 0.1 BTC UTXO that Alice now controls.
Ah, okay. So
Right.
the inputs, 0.7, equal the outputs, 0.6 plus 0.1, plus maybe a tiny bit for the fee.
Exactly. The sum of inputs has to equal the sum of outputs plus the transaction fee, which goes to the miner.
So let's circle back. What does this all mean for how Bitcoin looks to a user?
It goes back to what we said at the start.
Mm-hmm.
Bitcoin isn't storing a running balance anywhere.
Nope. No central ledger balance.
So when I open my wallet app and it says I have, 1.2 BTC, what's it actually doing?
Good question. Your wallet software is essentially scanning the blockchain for all the UTXOs that belong to the addresses it controls.
Okay.
It finds all those unspent envelopes, adds up their values, and then it shows you that total 1.2 BTC in your example as your balance. But behind the scenes, it's just a collection of separate UTXOs.
Wow. Okay. That's a fundamental difference.
It really is.
Yeah.
And this whole design, this UTXO model, it leads to some really key characteristics that define Bitcoin.
Like what?
Well, first, as we've said, it's stateless. The network itself doesn't track balances. Only the state of these UTXOs are if they spent or unspent.
Second, it's fully traceable. Every single output, every UTXO can be traced back through its transaction history to the inputs that created it and so on, all the way back to when the coins were first mined.
A complete history.
The complete unchangeable history on the blockchain. Third, it's potentially privacy enabling. Because you don't have to reuse addresses, and because change goes to new addresses, it can make following the flow of funds harder than if you just had one account number.
That traceability you mentioned sounds like the opposite of privacy.
Ah, yeah, that's the fascinating paradox, isn't it? Bitcoin offers pseudonymity. Your real name isn't directly tied to your address on the chain. But the UTXO model creates this incredibly detailed, transparent ledger of all transactions.
So, traceable but anonymous-ish.
Sort of. Pseudo-anonymous. While the design allows for privacy techniques, the transparency means that if someone can link even one of your addresses to your real identity, they could potentially unravel your entire transaction history using this UTXO traceability. It's this constant tension.
Okay, that makes sense. It's a trade-off.
Exactly. And finally, the whole system is deterministic. Given the inputs, you can mathematically verify the outputs and the entire flow of funds in a transaction. It's all verifiable.
Okay, this is where it gets really interesting, I think. For investigators, for analysts, this UTXO model is, like you said, both a challenge because of the privacy features, but also an incredibly powerful toolkit because of the traceability.
Absolutely. It really makes you appreciate the cleverness of the design, right? That this whole huge decentralized system relies on managing these simple unspent outputs.
Yeah, it does.
And those characteristics we just talked about, they directly lead to how UTXOs are used in forensic analysis.
So what are some of those forensic use cases?
Well, the most obvious one is tracing funds, following the BTC from input to output, transaction to transaction. That's bread and butter on-chain investigation.
Following the money.
Following the digital money, exactly. Then there's detecting obfuscation. Things like coin join services or mixers.
Yeah.
They try to break the UTXO links by pooling funds from many users and sending out new mixed UTXOs.
Trying to muddy the waters.
Right. But the way they do this often creates specific patterns in the UTXOs, like many inputs consolidating, then splitting into many equal value outputs. Analysts look for these signatures. It's like a fingerprint of mixing activity.
Interesting. What else?
Wallet attribution. This is huge. Trying to figure out which different Bitcoin addresses are likely controlled by the same person or entity.
Grouping addresses together.
Exactly. And then, of course, scam and laundering detection. Investigators look for common patterns used by criminals. Things like consolidation, where lots of small UTXOs from, say, scam victims are gathered into one address.
Gathering the loot.
Yep. Or layering, where a large illicit UTXO is broken down into many smaller ones and moved through a complex series of transactions to hide the source. Or tumbling, which is rapid movement between addresses. All these leave tracks in the UTXO history.
And how do they actually do that attribution or spot those patterns? You mentioned heuristics earlier.
Right, heuristics. These are like rules of thumb or strong indicators that analysts use. Probably the most famous one is the multi-input heuristic.
Okay, what's that?
The idea is simple but powerful. If a single transaction spends UTXOs that belong to two or more different addresses,
Yeah.
it's highly probable that all those input addresses are controlled by the same entity. Because, well, who else could authorize spending from all those different addresses in one go?
Ah, okay. That makes intuitive sense. You need the private keys for all of them to make the transaction.
Exactly. So seeing multiple addresses feed into one transaction is a super strong clue for wallet clustering, grouping those addresses together under one potential owner.
That seems like a cornerstone for investigators. But I wonder, are there legitimate cases where different people might pool funds in one transaction? Could that lead to mistakes?
That's a really important question. And yes, it's not a 100% perfect rule like most heuristics. There are scenarios, though less common, like perhaps certain types of crowdfunding payments or, more technically, complex multi-signature setups where inputs might legitimately come from different controlling parties.
So analysts need to be careful.
Absolutely. They don't rely on just one heuristic. They look for patterns, corroborating evidence, maybe the timing of transactions, the types of wallets involved. It's about building a case based on the weight of evidence, not just one clue. It's probabilistic.
Okay. What other heuristics are key?
Another big one is change address detection. We talked about how wallets send leftover change back to the sender, usually to a brand new address that hasn't been used before.
Right, for privacy.
For privacy, yeah. But this creates a pattern investigators can often spot. They see an output in a transaction going to a fresh, unknown address, and maybe the amount looks a bit random or odd. It doesn't match the main payment amount.
The leftover amount.
Exactly. That's often a strong indicator that it's the sender's change address, linking it back to the input addresses.
Let's try putting this together with that practical example from the source. It's like a mini mystery.
Okay, let's do it.
So imagine you're watching the blockchain and you see a suspicious wallet address receive a fairly large amount, say 2.5 BTC.
Okay, 2.5 BTC coming in.
And you look at the transaction that sent it, and it has 8 different inputs feeding into it.
8 inputs, 1 output of 2.5 BTC.
Got it. Now you dig a bit deeper. One of those 8 input addresses is already flagged. It's known to be part of a scam operation.
Okay, 1 known scam address.
But the other 7 input addresses, they're not tagged, and looking at their history, they seem to have only ever been used in this one specific transaction as inputs.
Ah, okay. So 1 known bad actor, 7 unknown addresses,
Yeah.
all contributing funds together in one go.
Right. What can an analyst infer from just that?
Well, quite a bit, actually. First, invoking that multi-input heuristic.
The one about shared spending.
Yeah. It's extremely likely that those 7 unknown addresses, plus the known scam address, are all controlled by the same person or group. Probably the scam ring consolidating their funds.
Makes sense. Pooling the money.
Exactly. So, inference number 2. This transaction itself is almost certainly a wallet consolidation. They're sweeping funds from various collection addresses into one main one. This is super common before trying to cash out or launder the money.
Gathering it all up before moving it again.
Precisely. And that leads to the third point. What to do next? By identifying that 2.5 BTC output address as the consolidation point, investigators now know where to focus. Monitoring that address is crucial, as it will likely reveal the next steps in their laundering process where the money goes downstream.
Wow. Just from looking at the inputs and outputs, it really does change how you think about digital money, realizing it's these traceable chunks moving around.
It absolutely does. When I first started really digging into this, tracing transactions hop by hop, it felt almost like digital archaeology. You're uncovering the layers based on these spent and unspent outputs.
Cool analogy. Okay, so to make sure we have the full picture, there are a couple of related ideas we should probably touch on too.
Yeah, good idea.
First, transaction fees. You mentioned them briefly. How do they fit into the UTXO model?
Right. So the fee paid to the miner, who includes the transaction in a block, isn't like set explicitly as a separate field in the transaction data.
Oh, how's it calculated then?
It's simply the difference between the total value of all the inputs used and the total value of all the outputs created.
Ah, inputs minus outputs equals fee.
Exactly. Total outputs, transaction fee. It's implied by the values. Miners prioritize transactions that offer a higher fee relative to their size.
Got it. Then there's dust transactions. We touched on this too, these tiny amounts.
Yeah, dust. These are UTXOs with such a small Bitcoin value, like maybe just a few cents worth, sometimes even less, like 0.0000005 BTC or something tiny.
Why do they exist?
Well, sometimes they're just leftovers from previous transactions, but they can also be created intentionally, sometimes used in spam attacks to bloat the blockchain, or maybe to try and tag addresses by sending them tiny amounts, or even just for testing purposes. They're often uneconomical to actually spend later because the fee would be higher than their value.
Okay. And lastly, wallet clustering. We keep mentioning it. It's basically using these UTXO heuristics, like the multi-input one, to group addresses together.
That's the core of it, yes. It's a fundamental technique in blockchain OSINT. You apply these heuristics repeatedly to transactions, gradually building up clusters of addresses that you assess, with some probability belong to the same entity. Is how analysts map out the holdings of exchanges, darknet markets, or illicit actors.
Right. Putting the puzzle pieces together.
Exactly. Though it's worth noting, sophisticated users might employ techniques specifically designed to try and break these heuristics, making clustering harder.
Okay. For listeners who want to actually try some of this or just see UTXOs in action, are there specific tools you'd recommend?
Yeah, definitely. For just basic exploring and tracing, a good block explorer like blockchain.com Explorer is a great start. You can click through transactions and see the inputs and outputs.
Okay.
To see things more in real time, like transactions waiting to be confirmed, mempool.space is fantastic. It gives you a great view of the mempool, that's the waiting area,
Yeah.
and UTXOs.
But mempool.space, got it.
For more advanced analysis, especially trying to link addresses to known entities like exchanges or companies, Arkham Intelligence is pretty powerful. They use AI and data aggregation for that.
Archon.
And
Yeah.
then if you're talking professional commercial-grade tools used by investigation firms and law enforcement, you're looking at platforms like Chainalysis Reactor or TRM Labs. They offer very deep analytics and clustering capabilities.
Good list. So let's try and summarize the main takeaway here for anyone doing OSINT in crypto, or really for anyone just trying to understand Bitcoin.
Yeah, the absolute core thing to internalize for you listening is this. Bitcoin is tracked via UTXOs, not account balances.
No balances, just
It's-
UTXOs.
Right. When you see a balance in a wallet, that's just the sum total of all the individual unspent UTXOs that wallet currently controls. It's a collection of those envelopes.
Okay.
And every single transaction is basically a puzzle. It takes some UTXOs as inputs, consumes them, and creates new UTXOs as outputs. Your job, if you're analyzing, is to reconstruct that picture. Figure out where the inputs came from and where the outputs went.
And that tip from the source material seems like a perfect mantra for that. Always ask, where did each input UTXO come from? Who might own it? And where did each new output UTXO go?
Exactly. Asking those questions, transaction by transaction, that's how you build understanding and trace the flow.
So maybe a final thought for people to chew on.
Yeah, think about this. Now that you understand this fundamental UTXO structure, how does that change the way you view Bitcoin transactions going forward? Does it make you think differently about privacy or security or even just how you manage your own coins?
That's a good question to ponder.
And if you want to explore it more actively, here are a few suggestions. Go to a block explorer, pick a random transaction, and actually try to trace the UTXOs. See where the inputs came from, follow an output to the next transaction.
Get hands-on.
Get hands-on. Try to spot what looks like a change address based on the amount or it being a new address. Look for transactions with many inputs, maybe a consolidation.
Practice identifying those patterns.
Yeah. You could even invent a mini case study for yourself.
Sure.
Track funds from one point to another and just document the flow of the UTXOs involved. The more you actually look at the raw data with this UTXO model in mind, the clearer those patterns will become.